Take a look at the device you're using right now. Whether it's a modern smartphone, a sleek new laptop, or a desktop running the latest AI models, none of it, and I mean absolutely none of it, would exist without a single, relatively unknown Dutch company. Welcome back to Market Planly. In today's explainer, we're pulling back the curtain on a company that doesn't just participate in our modern economy, it literally dictates its physical limits.
So what exactly is the most strategically important company you've probably never heard of? Well, it's ASML. They are the undisputed absolute monopolist in something called sub-7 nanometer photolithography, which is basically an incredibly complex way of using light to print microscopic circuits onto silicon. Simply put, if you want to manufacture the world's most advanced AI accelerators, high-performance CPUs, or top-tier memory chips, you have to go through ASML. They are the physical gatekeeper of the entire digital age.
Right. Let's dive into their origins, because going from a leaky shed to absolute global dominance is quite the story.
To truly appreciate their absolute dominance today, we have to rewind to their highly speculative beginnings back in 1984. They started out operating in a leaky shed in the Netherlands as a struggling joint venture between Philips and ASML, and honestly, their first product was a total commercial failure. They were just getting crushed by industry giants like Nikon and Canon. But then, a moment of pure serendipity hit in 1987. A new company in Taiwan, you might know them as TSMC, took delivery of their very first ASML machines. Shortly after, a massive fire destroyed the Taiwanese facility. TSMC ended up using its insurance payouts to reorder those exact same machines, which effectively doubled ASML's order book overnight. That catastrophe actually forged a vital, lifelong strategic alliance that saved ASML from the brink and eventually propelled them to a highly successful IPO in 1995.
Okay, so how did they completely corner the market? It all comes down to mastering Extreme Ultraviolet technology, or EUV. It was essentially engineering the impossible.
You see, as the tech industry kept demanding smaller and faster chips, traditional light sources hit a hard physical wall. They simply couldn't print circuits that small anymore. The industry had to transition to a mind-bending wavelength of 13.5 nanometers, extreme ultraviolet light. And generating this light, it's one of the most complex engineering feats in human history. Here is how it works. ASML machines literally shoot a stream of molten tin into a vacuum chamber at a blistering rate of 100,000 droplets every single second. Then, a pre-pulse laser zaps the tin to flatten it out like a pancake. Immediately after, a massive 15-megawatt industrial laser blasts that flattened tin, vaporizing it into a highly ionized plasma. And it's that plasma that finally emits the EUV light. It is just an incredibly visceral, violent process happening on a microscopic scale.
And the extremity of this engineering marvel is hard to overstate. That tin plasma we just talked about, it reaches temperatures between 220,000 and 500,000 degrees Celsius. That is literally hotter than the surface of the sun, and it's happening inside a machine right here on Earth. But here's the craziest part. The energy efficiency of this whole process is a mere 0.02%. It takes nearly a megawatt of electricity to yield just a few hundred watts of usable EUV light.
Which brings us to the next massive hurdle. Because EUV light is so incredibly delicate, it gets absorbed by almost everything, including thin air and regular glass. So the entire optical path has to take place inside an ultra-high vacuum. ASML partnered with the German optics giant Zeiss to design perfectly smooth, perfectly curved mirrors to guide the light. But even with the absolute most advanced mirrors on the planet, about 30% of the light is lost as heat every single time it bounces. By the time that light actually hits the microchip wafer, the cumulative light loss is just staggering.
Naturally, you might be wondering, if this is all just physics, why hasn't anyone else copied them? Well, it's because ASML has built an indestructible moat.
ASML isn't really a traditional manufacturer. They're more of a system integrator. In fact, they only build about 15% of the machine components in-house. What they've done is build the ultimate economic moat, with incredibly high barriers to entry and massive pricing power. Back in 2012, through something called the Musketeer Project, ASML convinced their biggest customers, Intel, TSMC, and Samsung, to actually buy equity stakes and co-fund the immense long-term research required to make EUV a reality. They financially locked in their customers before the machines were even finished. This fiercely protected their intellectual property and created an insurmountable structural advantage, deeply embedding them into the industry's network. But their real secret weapon? It's their supply chain. ASML relies on a hyper-specialized network of over 5,000 global vendors. At the very top of this sits the Dutch-German triad.
Zeiss in Germany is the absolute sole supplier of the massive 12-ton optics required for the newest machines. Another German company, Trumpf, is the exclusive provider of those high-power lasers we mentioned earlier. This is a deeply symbiotic relationship. One executive even called it a virtually merged company. If a competitor wanted to rival ASML today, they wouldn't just have to figure out ASML's tech, they would have to spend decades rebuilding equivalents of Zeiss and Trumpf entirely from scratch.
And ASML isn't slowing down. They're pushing the boundaries even further with their next-generation high-NA UV machines, which are designed to print even smaller, denser transistors. But these machines cost an eye-watering $350 to $410 million each. That astronomical cost has forced a major strategic divide across the foundry industry. Intel has jumped right in as an early adopter, hoping to reclaim their manufacturing leadership. Samsung and SK Hynix are following closely behind in 2025 and 2026. But TSMC, the undisputed king of chip manufacturing, is taking a very different route.
TSMC has decided to delay adopting high-NA EUV until roughly 2029. Why? Mainly to avoid those massive depreciation costs. Instead, their strategy is to maximize the lifespan of their older standard EUV machines. They're doing this by using a technique called multi-patterning, which essentially means running the silicon wafer through the machine multiple times to achieve the same intricate designs. It's a highly calculated bet on capital efficiency over hardware-led scaling.
Now, because this technology is so critical, it sparked a massive technology war, placing ASML right in the crosshairs as a geopolitical weapon.
Because ASML's technology is the absolute bottleneck for advanced chips, the exact same chips that power modern AI and next-generation military applications, the company is sitting squarely at the center of a geopolitical technology war. Access to ASML's machines literally dictates which countries can manufacture the world's most advanced semiconductors. Since 2019, under coordinated policy pressure from the US and Dutch governments, ASML has been banned from exporting its EUV scanners to China. Verified historical facts show that China has responded to this with a dual-track strategy. First, Chinese chipmakers like SMIC are taking older, unrestricted ASML deep ultraviolet machines and using that extensive multi-patterning technique to successfully fabricate 7nm and 5nm equivalent chips. Now, analysts do know that this approach suffers from high defect densities and elevated costs, but concurrently, they are aggressively pushing for domestic self-sufficiency.
And that brings us to Project WuXi, which is a massive state-funded consortium effort in China. Reports indicate that a functional prototype of a domestic EUV system was actually approved in late 2025, utilizing a different laser-induced plasma light source. However, while the prototype exists, leading expert analysis suggests that transitioning from a lab prototype to a reliable, production-grade scanner is going to be incredibly difficult. Because of the need for sub-nanometer stabilization and the lack of that massive sub-supplier ecosystem we discussed earlier, experts estimate China likely won't be able to deploy a commercially viable domestic EUV system before 2028 or even 2030.
So could disruption come from somewhere else entirely? Some point to Canon's nano-imprint lithography, or NIL. NIL is a completely different approach. Instead of using complex light optics, it's essentially a high-tech mechanical stamp that physically presses the circuit design directly into a resin on the wafer. The huge upside is that it uses about 1/10 the power of an ASML machine and is much cheaper. But because it relies on physical contact, a single speck of dust can damage the stamp, which then propagates defects across every subsequent wafer. While it's great for simpler memory chips, analysts widely agree it poses absolutely no near-term threat to ASML's dominance in complex logic chips. So, where does all of this leave ASML financially? Well, in an incredibly strong position. The AI boom and the global rush to build new semiconductor fabs have fortified the company's financials, locking in massive margins. They finished out 2025 with nearly 32.7 billion euros in net sales and an order backlog sitting at a staggering 38.8 billion euros. This gives them almost complete revenue visibility all the way through 2027, and looking ahead, by 2030, they're targeting up to 60 billion euros in revenue.
Ultimately, there is a quote that perfectly summarizes this entire situation. ASML doesn't make chips, they make the machines that make the chips. By orchestrating an unmatched global supply chain, they have literally transformed the laws of physics into a commercial monopoly. That makes them, without a doubt, one of the most strategically important entities on planet Earth.
I really hope you enjoyed this deep dive into ASML. If you love business, finance, technology, and economics explained in a simple, engaging way, please hit that subscribe button and join us here at Market Plainly. Also, I would absolutely love to hear from you. Leave a comment below and let me know, do you think any company could realistically challenge ASML's dominance in the next decade? And what company would you like to see us feature next? Speaking of what's next, you definitely won't want to miss the next explainer in our Business Empire series. We're going to be looking at the very company that buys these massive ASML machines to manufacture chips for Apple, NVIDIA, and AMD. Join us next time as we explore why TSMC is the world's most important company. They sit at the absolute center of the global technology supply chain, and it's a story you won't want to miss. Thanks so much for watching, and I'll see you in the next one.